Hello. How's everyone doing? Trying to survive. Okay. Do you have a lot of tests again? Okay. Last week was bad. Well, last week was the first week after reading week, so it's always bad. Only 236 meter. Well, 236 meter gave you a whole week to do it, right? So you can pick any time in a week and find 1 hour to do it. So I think we don't have to do it right now. Yeah. I still don't know. Honestly, I still don't know what's the difference between the meter and the homework she's talking about. It seems like the same thing. But she's like, oh, it's not. Yeah, I think it's the same. And then she's like, oh, it's not a meter, it's a timed homework. Isn't that the same thing? Yeah. And I don't even know what's it gonna be about. It's not really take home meter. So she's given them a whole week, but once you open it, you only have 1 hour to finish it. So it's like a meter, except you can do it anytime you want during the whole week. So yeah. Is 236 supposed to have proofs? I don't think so. 236 is a computation course. Well, as far as I know, it's always been a computation course. It's uh well, I don't know, cause like I never took the course before. For me, I personally never took 236, but from what I know, the course is a computation course. It's like a continuation of 232. How is Math 102 since you TA'd it? I'm not TAing a Math 102 anymore. I'm TAing 3 other courses. So when I applied for TA-ship, I said anything but Math 102, but did not expect them to give me something that I've never taken before. Well, if they think I'm qualified, then sure. I got the course waived when I was in undergrad, like 236, because I know the material already. So I didn't bother to take it. And now they're asking me to TA it. Anyway, any other question? Either it's related or unrelated. All good? Okay. So let's start today's tutorial. Today's tutorial is basically a 232 review. Honestly, there's not much new things. The whole system of linear equations is like a 223 review. So as I mentioned before, you need to know how to find the eigenvalue and eigenvector of a matrix. So today we'll do a lot of questions about that, and we'll see how that can help you find the general solution of a system of linear equations. So first of all, system of linear algebraic equations. So if you have, well, there's a typo here, it's supposed to be 2. Don't know why I typed that here. So a11 x1 plus a12 x2 plus all the way to a1n xn equals to b1, an1 x1 plus an2 x2 plus all the way to an xn equals to bn. This whole thing can be written as a matrix times x equals to b. So this matrix A, hopefully everyone still remember. So this matrix A is gonna be the coefficient of your equations. So that's gonna be a11, a12, to a1n, and then here an1, an2, all the way to ann. So this is just linear algebra. Okay. So this is your A x equals to b. So if your b, so your b's is all 0. So when I say b equals to 0, they meant b equals to 0, 0, 0, 0, 0, like this. Okay. Now this system is called homogeneous. Otherwise, it's called non-homogeneous, which is the same in 2 to 3. Hopefully, you still remember those. If not, it's okay. We're trying to review this part anyway. So eigenvalues and eigenvectors, the equation ax equals to y can be viewed as a linear transformation that maps a given vector into a new vector. To find such vectors, we have y equals to lambda x. So lambda is going to be eigenvalues. Okay, so your lambda is a scalar propositionality factor and 6 solutions for this. So basically, you let this equal, move it to the other side, you'll get this, and the determinant of this equals to 0. So this is how you find your eigenvalue if you don't remember. Okay, so this is find eigenvalue. And after you find your eigenvalue lambda, you use this equation to find your eigenvector. Okay. And for your eigenvalues, we would have 3 different cases. You could have, just like before, you could have real distinct. So real lambda, and for real you can have distinct and repeated, and you could have complex lambda as well. Okay, so we will see, let me think, today we will see the first 2 cases, so I guess we'll do the last cases next week. And for each of the lambda, you can find the corresponding eigenvector, but sometimes when you have repeated eigenvalues, if you can only, for example, you have 3 you have 3 eigenvalues and they're equal to each other, but you can only find one independent eigenvector, then you need to do something else to find the other ones. So we'll see that today as well. Let's look at an example. Right now it's just 2 to 3. There is nothing new. So let's review 2 to 3 a bit. So I want you to find the eigenvalues and eigenvectors of the matrix A. So this is the first case when we have real eigenvalues. Okay, so I'll give you some time to work on this. It's 3 by 3 matrix. You might think it's really annoying to find the eigenvalues and eigenvectors, but for this course, it's most likely they will give you 3 by 3 matrix. So you should be used to it and should be really fast to find the eigenvalue and eigenvectors. So I'll give you some time and you can. If you don't know how to do this, make sure you review because the rest of the course are all related to eigenvalue and eigenvector. Okay. Okay, it looks like most of you got it already, so I'll briefly talk about it and we'll move on. So basically you solve the determinant of this matrix. Okay, a 3 by 3 matrix. Find the determinant of this, make it equals to 0. Then you'll get lambda 1 equals to lambda 2 equals to -1, and lambda 3 equals to 2. Since this has multiplicity of 2, you're supposed to find 2 corresponding eigenvectors to this. So we let a minus lambda I v equals to 0. So you'll get this matrix. Basically, you just need to solve for this matrix and you'll get v1 equals to -1, 0, 1, v2 equals to -1, 1, 0. Okay, so that matches what you guys got as well. Yeah. And 1, so we have two different eigenvectors corresponding to this. When lambda equals to 2, you do the same thing. A minus lambda I times x or times v equals to 0. Then you get your v3 equals to 1, 1, 1. So is there any question about this? Question? Okay, seems like everyone got the same answer. So let's do example 2. So example 2 is when we have repeated eigenvectors or eigenvalues, and you would have, so you have one that has multiplicity of 2, and you can only find one eigenvector corresponding to this. Any other than this stuff, do we need to know anything else from 2 to 3? Did you guys learn matrix exponential? Linear combination, yeah, you definitely need to know that. Don't think you need to remember anything else. As far as I remember, that's for you covered matrix exponential in class. Yeah, I don't remember if that's covered in 223, but yeah, then you don't need to know it from 223. You'll learn it from this class. Anything else you need to remember? Probably review a series like power series, Taylor series. Those part, I don't think that's in 223. Probably 136 or 135 when you guys took it. I don't know. So probably review that part. Power series. Everything else should be okay. I think. Anyway, try example 2. If you want, you can write on the board too. Okay, so if we look at this one, you'll see that, well, we have eigenvalue with multiplicity of 2, but when you plug this in, you can only find one like eigenvector. So how do you find the other eigenvector? What you need to do is you use a minus lambda I v equals to v1. Okay, and whatever v you solve here is gonna be your v2. So we will have -1, -1, 1, 1, and then -1, 1. This will give you 1, 1, 1, 0, 0, 0. So you will have 1 minus t, which equals to 1, 0 plus t times -1, 1. So your v2 is gonna be 1, 0. Okay? Any question? Should be pretty simple. Yes, you use the first eigenvector you find to find the second one. So what you need to do is use this one. That's what you need to do to find the second one. Okay, so let's continue. So we have linear homogeneous system with constant coefficient. So again, you will have homogeneous system here. Okay, so that's gonna be y prime equals to ay plus g, where y equals to this. So basically you write it in matrix. I mean y prime equals to this. A equals to this, yeah. So basically, if you're given a system of OD, you can write it in matrix form, and then you can solve for your solve the eigenvalue and eigenvector in your matrix A, and using that, you can find the general solution, which we'll talk about it very soon. After you find the eigenvalue and eigenvector, how do you find the general solution? We'll talk about very soon. So linear system of ODEs is a system of first order linear ODEs such that g equals to 0. So we're talking about here this g equals to 0. So those are all zeros. Okay, so you have y prime equals to ay. Otherwise, it's called non-homogeneous, just like before. So for the rest of the tutorial, we will assume that A is an n by a matrix of continuous function everywhere in the interval that we discussed. So we have a principle of superposition just like before. If you have two solutions to the system, then the linear combination is also a solution to the system. So just like before, except now we have a system of linear ODEs. And then we have matrix of solutions. So after you got your solution, you can write it in matrix form. That's all it says. Now let's look at a simple example and just give you a taste of what system of linear ODE looks like. So I want you to verify that y1 and y2 are indeed the solution of this system of ODE. Okay, this one should be really simple. Give you 2 or 3 minutes to work on this, and then I'll take it up. Give us a hint how do you... Oh, it's like before. Basically, you need to verify these are solutions to this. So if you look at this, you have y prime, you have a matrix, you have y. So you need to show left hand side equals to right hand side when you plug this back in. So your first step is you need to find y prime. Okay, and then plug back y prime and y into this ODE, system of ODE, and see if if y left hand side equals to right hand side, just like before. Let's do this. This is pretty simple, I think. So we have y1 equals to e to the 4t, e to the 4t. So y1 prime equals to, let's write it as left hand side. So left hand side equals to y1 prime, which equals to 4e to the 4t, 4e to the 4t. Okay. And your right hand side is gonna be 1331 y1. So that's gonna be 1331 times e to the 4t, e to the 4t. This will give you 4e to the 4t and 4e to the 4t. So you show that your left hand side equals to right hand side. So my y1 is a solution. Okay, and you do the same thing for y2. So this will give you negative 2e to the negative 2t and 2e to the negative 2t. So you got left hand side equals to right hand side. So we know that y2 is also a solution. Okay? When they put number in brackets, doesn't that mean derivative? What do you mean number in brackets? Oh, you mean this? Oh, here I don't mean derivative. I mean just y1 and y2. Oh yeah. Okay, this might be confusing. Just consider it as y1 and y2, like this. Okay. Any other question? Okay. So let's look at the last example. So the last example, I'm giving you linear system of differential equations, this and this. First of all, I want you to rewrite the system as x prime equals to ax, where A is a 2 by 2 matrix and x equals to xy. And then I want you to find the eigenvalues and eigenvectors. And lastly, we will use the eigenvalue and eigenvectors to find the general solution. So I want you to do A and B first, and we'll do C together, okay? Do A part A and B, and we'll do C together. So I finished writing part A and part B. Let's talk about them first before we continue with part C. So we have two linear ODE. You write them as this form, then you can write it in matrix. So you have x prime, y prime equals to 1, -2, 2, -3. So how do we find the matrix? Is basically the coefficient of this equation, okay? So in this case, your A is this matrix x prime, capital X prime is x prime y prime, and capital X is xy. So in this case, you rewrite this whole thing as a system, as a matrix form. So that's part A. Part B is just asking you to find the eigenvalue and the eigenvectors of matrix A. This is just as before, so first of all we find the characteristic polynomial, which is this, make it equals to 0. Okay, then you'll get lambda 1 equals to lambda 2, which equals to -1. Now, you see that we have multiplicity of 2, so you're supposed to find 2 eigenvector, but once you plug in lambda equals to -1 to this, you'll find 1 eigenvector, which is 1, 1. So what you need to do is you need to use this eigenvector to find the second one. So the second one you can find, the second eigenvector you can find is actually not unique, so it's possible that you find something else. But the one I used is 1/2, 0. Okay. So right now we have eigenvalue, we have eigenvector. How do we find the general solution? So let's ignore this initial value first. Let's just first talk about the general solution. So I'll tell you that once you find your eigenvalue and eigenvector, your general solution, so it's gonna be, you'll get the first solution from here, okay, and then you'll get your second general solution, second solution from here. So it's gonna be x1 is gonna be equals to e to the power of negative t. So it's gonna be e to the power of lambda tv. That's gonna be your solution. Okay, so in this case you'll get e to the power of -t v1, and from v2 you should get, so since we got v2 from v1, you need to multiply this term by t first, and then plus another term that uses this. So in this case, you would have t times e to the -t v1 plus, okay, e to the -t v2. You cannot miss this part, okay? So you need to multiply by t. Yes, because it's repeated. Okay. So you need to multiply by t on the original one and then add your new one. So general solution, those are the two solutions we found. The general solution is gonna be, well, you add constant to at the front, right? So you will get x equals to c1 x1 plus c2 x2. So let's write it in matrix form. So you will get c1 x1 is c1 e to the -t v1. v1 is 1, 1. So c1 e to the -t, and then plus c2 x2. c2 x2 is t e to the -t v1. So that's going to be t e to the -t plus e to the -t v2. So you have 1/2 here. So that's going to be c2 t e to the -t plus c2 let's put 1 over 2 here. So plus 1 over 2 C2 e to the negative t. Okay, and the second entry is going to be C1 e to the negative t, since it's 1, 1, and then plus C2. So C2 x2, x2 here is 0. I mean V2 is 0, so we don't have this term, we only have this term, and here is 1. So we will have C2t e to the negative t. That's gonna be your general solution without finding the constant using the initial value here. Okay, so that's your general solution without finding the constant. Now let's plug in initial value. We know that x0 equals to 1, 2. So we plug in t equals to 0. That's gonna give you C1 plus C2 plus 1 over C2, and down here is C1 plus C2. And this whole thing equals to 1, 2. So that's gonna give you C1 equals to 3, C2 equals to negative 2. So finally, your general solution is just this, and plug in C1 and C2. So x equals to 3 e to the negative t minus 2t e to the negative t, and minus 2 times 1 over 2 is negative 1, and 3e to the negative t minus 2t e to the negative t. Okay, so this is your T2 shouldn't be there. Wait, hold on. Did I make a mistake? Where are you talking about? C2. T. Ah, I see. Here. You're talking about here, right? Oh, here. Never mind. Then I need to recalculate it. This is correct, right? Let's see. Yeah, this is correct. C1 is 2. Let me just... T is 1. Yeah. So the C1 is 2, C2 is minus 2. Still minus 2. 2 plus minus... Yeah, it's still minus 2. So C1 is 2. So 2, 2. I think this is good. Okay, any other question? Yeah, so basically this is how you use eigenvalue and eigenvector to find a general solution of a system of ODE. If no question, that is the end of the tutorial. You guys can leave. Send the file of the sheet again. Yeah, sure. If you're in the second tutorial, we haven't started yet. Okay. Hello. Well, mature fronted needs to show up here on a quiz. I don't even know what your quiz is gonna cover. What's your quiz gonna cover? Homogeneous equation and Moleskine? Let me see. Well, what I'm doing today is a material starting this week, I think. Just let me have a look.